My dear students, welcome to today's online class. I think in the previous class we discussed searching, right? In the searching we have two types, linear search and sequential search. In the previous class we discussed the types of searching and also we discussed the differences between linear search and binary search. Let us start today new topic, that is insertion. This is also one of the operation we can perform on non-primitive data structure, right? Now we are discussing a concept called one-dimensional array, right? So we can perform insertion operation on one-dimensional array also. So what is insertion? How we can perform this insertion on a one-dimensional array means, see here, insertion is a process of adding a new element into one-dimensional array. Right? So what is the insertion? Insertion means it is a process of adding a new element into the one-dimensional array. Right? So let us see here exactly what is mean by insertion means. Insertion refers to inserting an element into the array. Right? What is the insertion? Insertion refers to inserting an element, means new element into the array. When an element is to be inserted into a particular position, all the elements from the asked position, means where we want add, that position is asked position, right? What is this? When an element is to be inserted into a particular position, all the elements from the asked position to the last element should be shifted into the higher order position. Right? What is this? Consider an array. Say it is an array, right? Right? 10, 20, 30, 40, 10, 20, 30, 40, 10, 20, right? 10, 20, 30, say this is 50, right? Means let us consider an array A with elements 10, 20, 30, 50 in the position. Array is A means first element is going to be stored in A of 0, second element is going to be stored in A of 1, third element is going to be stored in A of 2, fourth element is going to be stored in A of 3, fifth element is going to be stored in A of 4, right? So consider an array A with the following elements 10, 20, 30, 50. Now this is called array before insertion. This is called array before insertion. Before insertion. And let us consider a new element. New element that is equal to 40. Okay, let us consider a new element 40 and it should be inserted at the position A of 3, right? Say this is 40, this is 50, and let us, here 30 is missing, right? Then it is very easy to understand. See here, let us consider an array A with the element 10, 20, 40, 50 in the memory locations A of 0, A of 1, A of 2, A of 3 respectively. Then a new element, consider 30, is to be placed in the third position. That is to be placed in the third position. Third position means 1, 2, 3, right? Here we have to place, means in A of 2 we have to place what? 30. We have to in the third position, right? That is new element 30 is to be placed in third position. That is 1, 2, 3. In the third position means A of 3 we have to place 30. How it is possible? He says, let A be an array with 10, 20, 40, 50 and 30 has to be placed in the third position. That is A of 2 means. So this is insertion we have to perform, means insertion is take place moving inserted position into the last position element to the higher order. What he says, when an element is to be inserted into a particular position, suppose particular position means we have to place this 30 in A of 2, third position means A of 2 means what we have to do, particular position, all the elements from the asked position to the last element should be shifted into the higher order. All the elements from the asked position to the last element shifted to the higher order. Means here asked position is A of 2. Means what we have to do now means asked position to last position we have to move into the higher order. Means what is there in A of 2 that is placed in A of 3, right? And what is there in the next element means A of 3 that is shifted to higher order means A of 4, that is shifted to A of 4 until we have to place last element, that is n minus 1th element is placed into the next order. Then what happens? See here. So asked position is A of 2 means in A of 2 what is there? 40, that is shifted to higher order means A of 3, right? So A of 2 ಅಲ್ಲಿ ಏನಿದೆ at present 40 ಇದೆ, ಅದು ಹೈಯರ್ ಆರ್ಡರ್ ಅಂದರೆ A of 3ಗೆ ಶಿಫ್ಟ್ ಮಾಡಿದರೆ A of 3ಗೆ ಶಿಫ್ಟ್ ಮಾಡಿದರೆ 40 A of 3 ಅಲ್ಲಿ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಆರ್ಡರ್ ಯಾವುದು? A of 3. A of 3 ಅಲ್ಲಿ ಏನಿದೆ? 50 ಇದೆ. ಇದು A of 3 ಅಲ್ಲಿ ಇರೋದನ್ನ A of 4ಗೆ ಶಿಫ್ಟ್ ಮಾಡಬೇಕು, ಅಂದರೆ A of 4 ಅಲ್ಲಿ 50 ಬರುತ್ತೆ, ಹೌದಾ? ಅಂದರೆ A of 4ಗೆ 50 ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ A of 2 ಎಂಪ್ಟಿ ಆಗುತ್ತೆ. A of 2 position is empty. Now we have to place in the place of A of 2 new element, that is we have to place this 30 to A of 2, right? So simple process. What is mean by insertion means adding a new element into the array is called insertion. How this is possible means we have to place inserted position element into the last element into the higher order. What he says, all the elements from the asked position to the last element should be shifted into the higher order. See here, this is before insertion. Now see what happens after insertion. After insertion ಏನಾಗುತ್ತೆ ನೋಡಿ, A is the array, right? A of 0 to A of 3 ತನ ಎಲಿಮೆಂಟ್ ಇದೆ. A of 0, A of 1, A of 2, A of 3, right? See here A of 0 10 as it is, A of 1 20 as it is. See here, we have to place this 30 in the third position, that is 1 2 3, means we have to place 30 in A of 2, right? In A of 2 we have to place 30. How it is possible means we have to place inserted element position to its higher order. So where we have to insert in A of 2, what is there in A of 2? 40. So this 40 we have to place into the higher order, means in A of 2 40 is there, we have to place this A of 2 in A of 3. So in A of 3 place 40. Next position A of 3, in A of 3 50 is there, we have to place this A of 3 element to A of 4. So this 50 is placed in A of 4, right? So all the elements are over. Now see here, inserted element position is A of 2, so this is empty. Now A of 2 is empty, we have to place 30 in third position, that is A of 2. So now we have to place this new element into the 30 into this empty position. So this is what after insertion. After insertion means simple thing, what we have to do means we have to enter a new element into the array, means he says all the elements from the asked position, means where we have to add a new element, we have to add a new element into A2, right? So all the elements from the asked position to last element are placed in the higher order, right? So in the A of 2 we have to add 30, therefore take what is there first in A of 2 and place it in A of 3. So in A of 2 40 is there, we are placed that 40 in A of 3. A of 3 50 is there, we placed A of 50 in A of 4, right? So like this we have to place a new asked position to n minus 1th element to higher order, then asked position is empty, that is A of 2 third position is empty. So in that position we have to add third element. So this is what before insertion, this is what after insertion, right? See here, now I am going to write the algorithm for this insertion operation. Algorithm for insertion operation. See here, step 1, start of algorithm. Step 2, for I equal to n minus 1 to P, that is A of I plus 1 is equal to A of I. Step 3, A of P is equal to item. Step 4, n is equal to n plus 1. Step 5, exit athwa stop, right? That is end of algorithm. See here, first step is start, second step is for I equal to n minus 1 to P. Here n is nothing but number of elements in the array, P is the position where a new element is to be inserted. right? N is the number of elements, P is the position where new element is going to be inserted. See here, for I equal to n minus 1 to P means what? Whenever we are going to insert a new element into the array means what we have to do? We have to place last element to its higher order. Next element into higher order, next element into its higher order, until we have to place inserted position element. So we have to first take where we have to insert that position element should be placed into the higher order. Like this we have to place last element into its higher order. So means after insertion array size is incremented, obviously, right? See here, before insertion 1 2 3 4 is the array size. Now after insertion 1 2 3 4 5 is the array size. Means after adding element array size is going to be increased like this here. That's why in the step 4 n equal to n plus 1 is taken. Let it be first concentrate on step 2 here. For I equal to n minus 1 to P means first we have to take n minus 1 means last position number. For I equal to n minus 1 to P means for I equal to n minus 1. First initialize I is equal to n minus 1 means last element. N minus 1 means last element. I is equal to last element. Afterwards A of I plus 1. A of I plus 1 means last element position plus 1. See here last element means here 50 is there. So last element A of I plus 1 means A of I means here A of 3. A of 3 plus 1 means A of 4. A of 4. A of I plus 1 means A of 4 is equal to A of I is equal to A of 3. I means here 3. It means simple thing. What is there in A of 3? In A of 3, 50 is there. That 50 is assigned to A of 4. That 50 is going to be stored in A of 4. See here. That's why 50 is there in A of 4. So next, once again I equal to n minus 1. So like this. So last element is shifted here. Last element is A of 3. It contains 50. That is moved to A of 4. Right. Next A of 2. A of 2 means 40. That A of 2 is moved to A of 3. Right. A of 3. Now A of 2 is empty. A of 2 is empty. So like this, this for loop works. Afterwards, A of P is equal to item. Means at present P value is 2. Right? P value is 2. Position is 2. So A of P is equal to item means A of 2 is equal to which item we have to insert? 30. A of 2 equal to 30. That's why 30 A of 2 30 is there. A of 2 30 is there. Right? A of 2 equal to item is 30. A of 2 30 is there. After inserting new element, array size is increased. That's why n is equal to n plus 1. So previously n is 4. 1 2 3 4. A of 3 is there. Now size is increased. That's why n plus 1 means A of 4. So like this it is possible to insert a new element into the array. Insert new element into the array. Right? Now let us see the another operation, that is deletion operation. So let us consider a next operation, that is called deleting an element from the array. 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 Right? So it is exactly opposite to insertion operation, where insertion means it is the process of adding new element into the array. Deletion process means it is the process of removing an element from the one dimensional array. Right? See here, what is deleting? Deletion refers to removing an element from the array. When an element is to be deleted from a particular position, all the subsequent shifted into the lower order position. Right? So whenever we are going to inserting an element into a array at a particular position means from the inserted position to higher order, all the element positions are incremented. Whereas in the deletion process, suppose we are going to delete an element from a particular position means, suppose one element is there in A of 2, suppose we are going to delete it from the particular position means, its next order elements are going to be decremented to its position. Means a element which is present in A of 2 that is removed means the element which is there in A of 3 that occupies A of 2. The element which is there in A of 4 that occupies A of 2, A of 3, like this. So here what happens? Subsequent shifted into the lower order position. Whereas in insertion, from the inserted element position to last element position, its element position is incremented. Whereas whenever we are going to remove an element from the array, from that when the deletion operation is going on means element which is there after deletion, that position is shifted to its lower order. For example, the element which is there in A of 2 is deleted means the element which is there in A of 3 that is going to occupy the position A of 2. Similarly, which is there in A of 4 that is going to be occupying position A of 3. That is, here insertion position is incremented. In the deletion process, position is delete. Position is new element is going to be stored in the lower order position. See here, I am going to explain it with a new example, with one example. That is, let us consider an array A. It contains element 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. Right? Here, 10 is going to be stored in A of 0. 20 is going to be stored in A of 1. 30 is going to be stored in A of 2. 40 is going to be stored in A of 3. 50 is going to be stored in A of 4. A of 4. Right? Suppose we have to remove this 30. We have to remove this 30 from the array means we have to delete element 30 from the array means of in the which is present at A of 2 means what happens? Right? So whenever we are removing it means no affecting previous memory locations. That is, A of 0 having 30, 10. A of 1 having element called 20. See, we are removing it this 30 from the array means what happens? Next element is going to be stored in A of 2, right? So therefore A of 2 have 40, and next element, that is 50, is going to be stored in A of 3. 50 is going to be stored in A of 3. 50 is going to be stored in A of 3. Means what happens here? Copy 32 item. What happens here? Copy element 30 into item, means this item element, means element 30 is copied into the deletion position. Afterwards what happens? Move number 40 to position 2. See, A of 2 element is deleted, right? So next position is A of 3, right? A of 3 means 40, that is move 40 to position where? A of 2, right? Previously where is 40? 40 is there in A of 3. Here deletion is going on, means we have to decrement the element position. Means previously 40 is there in A of 3. Now we have to decrement its position, means A of 2 is going to occupy 40, that is move 40 to position A of 2. Next move 50. Move, next element is 50 to position, decrement its position by 1, means A of 4 is there. Now we have to write A of 3. A of 3, we have to decrement its position. So that is A of 3 contains 50, A of 2 contains 40, right? So like this, whenever deletion operation is going on, means we have to move element to its decrement position from last element to insert deleted position. So like this we have to follow this procedure while deleting an element from the array. Deleting an element from the array. Now let us see the algorithm for this. Algorithm for deletion operation. Algorithm for deletion operation. See here. Step 1, what we have to do? We have to select item, right? So item is equal to A of P. Item is equal to A of P. Step 2, for I equal to P to n minus 1, P to n minus 1, A of I is equal to A of I plus 1. End of for loop. Step 3, n equal to n minus 1. Step 4, stop अथवा exit. Stop अथवा exit. See here, very simple steps, only 4 steps. First step is item is equal to A of P, means we have to first select position from where item is to be deleted. For here I am selecting a position A of 2. So what is there in A of 2? 30. So 30 is assigned to item, means first we have to decide which item we have to delete from the array. Next, for I equal to P to n minus 1, means where that element is going to be deleted, that position we have to take. That's why I is equal to P. I is equal to P to n minus 1. What we have to do? A of I is equal to a of I plus 1 means a of I means here I is equal to p to n minus 1 is there. P is means position where element is deleted. So where it is deleted, p means 2, present p is 2. So a of I means a of 2 is equal to a of I plus 1 means a of I plus 1 means 2 plus 1, that is a of 3. So a of 2 equal to a of 3 means what is there in a of 2? A of 2 is equal to a of 3 means what is there in a of 3? A of 3, 40 is there means this 40 is assigned to a of 2. Therefore in a of 2 we placed 40. Next, for p equal to for I equal to p to n minus 1. Next p is incremented, that is p becomes 3, that is a of 3 is equal to a of 3 plus 1, that is a of 4. What is there in a of 4? A of 4 contains 50. This 50 is assigned to a of 3, therefore a of 3 contains 50. A of 3 contains 50. Now I value becomes 4, right? So p to n minus 1, 4. What is there in 4? A of 4 is equal to a of 5. So all the elements is over, right? In a of 5 there is no element. So we are coming from this for loop. So next, after deleting an element, array size is decreased, whereas in after inserting element array size is increased. Therefore in the insertion algorithm we take n equal to n plus 1. This is the deletion, so array size is decreased, therefore n equal to n minus 1. N is equal to n minus 1. See here, in the previous array last element is there in a of 4. A of 4 is there. After deletion array size is reduced, means last element is going to come in a of 3. See here, 50, previously a of 4 is there. After deletion 50 comes in a of 3. A of 3, that is array size is reduced. Therefore we have to take n equal to n minus 1, right? So these are the very, very important topics, insertion and deletion. And there is a lab program on this insertion as well as deletion, right? Okay. In the next class I am going to continue another new topic. Thank you.